So we're going to do a quick problem to demonstrate linear programming, and we're also going to use Desmos to help us out with this. So here's the problem. You can copy it down here, and we're going to click over to Desmos and take a look at that there. So let me find my Desmos tab. There we go. So the first thing you'll notice is we have two inequalities that are sometimes called the natural constraints. That is, x is greater than or equal to 0 and y is greater than or equal to 0. So let me highlight both of those. And what you'll see is those inequalities overlap in the first quadrant. You can tell that because that's where things are shaded kind of a purplish pink as opposed to either one of those two colors by themselves. So what I suggest we do is just keep track of the fact that our answer is going to be in the first quadrant and not really shade those directly. So let me shut those off. Now the next thing to do is to graph these inequalities. Now if this were a face-to-face class, we'd be doing this by hand. I'd say, okay, well, we want to graph the equation first, and that's this line right here. Let me zoom down a little bit. And of course, I really only want that line in the first quadrant. That's all I need to see. So let me make a couple restrictions. You can make them this way with a curly brace. You can put x is greater than 0, and then another curly brace. And at the same time, I want y is greater than 0. You can't put these together in the same little set of curly braces. It just won't like it, but it will work here. And I'm actually going to copy that because I'm going to use that a few times here. Now, the other equation that I have is this one. And let's paste in those same constraints. So that way we're only seeing this where we need to, which is in the first quadrant. Now, typically speaking, what you do is you take a look at your inequalities and you pick a test point. My test point is this one over here, 0, 0. And with our test point 0, 0, I plug that in and take a look at this equation. Yeah, 0 plus 0 is less than or equal to 32. So we'd want to shade below that line. So that line is the red line here. Let's shade below that. And that would look like this. Now, of course, we're running the same problem. I don't want to see this outside the first quadrant. So let's just paste in my constraints again. And there you go. Now, we'll do the same thing with the second line. So that is our blue line right here. We want to look at that again with our same test point, 0, 0. 0 plus 2 times 0 is less than or equal to 48. So again, you're going to want to shade below that because 0, 0, 0 makes that inequality true. So let's put those constraints in and turn this on. Now, a lot of times I use the same color twice because it's a little easier just to see where that gets darkened, especially if you get a lot of constraints that you have to deal with. You can see where these regions overlap. That is, the shaded region overlaps here, here, and then down here. So those 3 points, and then of course 0, 0 as well. Those are the so-called vertices of our solution polygon. Whatever point maximizes or minimizes our special function, our objective function, it's going to be one of these. So, okay, let's see how we're going to test that. Here's the function that we want to maximize. And you can type in whatever you like. You can type in your initials, say P for parent, X comma Y. And then type in the function, 15X plus 20Y. I believe that was our function. Let me just double check back here. Yes, 15x plus 20y. So let's get back to Desmos then. And now what we need to do is we need to test where test the objective function with the points that are the vertices of our region. So 0 and 24. That's 0 for x and 24 for y. So let me type that in. P of 0 comma 24. And you can see that 15 times 0 is 0, 24 times 20 is 480. Okay. Now the nice thing about Desmos is that it's pretty easy, especially with our setup to find this point of intersection. Usually speaking, you would have to solve a small system of equations. These two equations, let me just highlight them here. These two equations, figure out where these 2 points intersect, but Desmos does that for us, so that's pretty sweet. So let's take a look at the objective function at P of 16 and 16. We get 560. There's one more point that we need to do. Do not test this point. That point is not part of our solution region. Our solution region is the dark region where everything overlaps. So the point we want to test is out here at 32 and 0. So let's give that one a try. So P of 32 and 0, again, gives us 480. Now, technically, I guess you would need to also look at 0 and 0, but kind of already know that at 0, 0, this function is going to be 0. So the maximum that this function can be with these constraints is at the point 16 and 16. Now, keep in mind, this point of intersection here might not always be your answer. It's going to depend on the form of the objective function. For instance, if I had that as a 35, let's make that a 35, then look at what happens. Then the maximum point is no longer at 16 and 16, it's at 32 and 0. So it kind of depends on what your objective function is. You do have to test all the vertices to find your minimums and your maximums, and they will occur at those endpoints. So hopefully that helps. And if you have some more questions, catch me in a Zoom session.